Okay, so this question was either answered really, really well with 5s and 6s out of 6, or not very well at all with sort of 1s and 2s. So there wasn't much in between. Let's have a look at why, and it's really about embracing that command term of explain. So you can't just talk about angular momentum. If you do, which you can just panic and say, right, what do I remember? Just dump some theory down. You can still get probably 3 marks by not even looking at the picture and not talking about it. You can just put some theory in. However, if you want full marks, you have to explain using the images that you've got. And the question actually tells you, it wants you to look at dive A and B. You can't ignore both dives because there's a clear change between the dives. And you should be referencing that. A2, B4 up to B6, we've got a change in body shape, and that's clearly going to change, not the amount of angular momentum, because that's conserved. Once that that impulse is applied to generate torque, turning force, once this is applied and she's in the air, or they're in the air, you cannot change the angular momentum until another force acts upon it. So for example, if we hit the water, we get friction from the water known as drag. That's going to reduce her angular momentum because we've got an unbalanced force coming into play. If you're a figure skater and you're turning and then you're touching the ice, turning and touching the ice, then it doesn't look like this. You've got regular increases of angular momentum. When you push off the ice, you push off the ice. But in this example, she applies her torque, her impulse to generate torque. She's airborne, and during this point here, all of this, she's conserved an amount of angular momentum. Arguably, this dive has a greater angular momentum, but we don't have the statistics, so we're not going to go there. We just have to talk about what we see. I've broken it down into 3 phases: takeoff, flight phase, and water entry. And that should give you some ideas about what you could have talked about. Before we show you an example then, let's just recap the key theory. Momentum is quantity of motion, so P equals mv, mass times velocity of an object gives us its P, its momentum. Angular momentum is exactly the same, it just means momentum amount around an axis. So some of you actually said that she's not rotating in this dive. Well, she is, because she's not going forward and then dropping. That's not what's happening. She's turning in the air about an axis that kind of goes, I can't really show it in this picture, but it goes from there through her body, and she's rotating around an axis like that. It's not a twisting one like we see with a figure skater. It's an axis that kind of runs through her body like this, and she's going around it. This dive is exactly the same. She's just going backwards, but it's exactly the same thing. She's going around an axis here. So angular momentum is the moment of inertia times angular velocity. Everybody knows what angular velocity is, how fast we spin around that axis. Moment of inertia is trickier, but let's look at inertia. We know what that means, resistance to motion. If you've got a centre of mass or you've got an axis of rotation, the closer you bring your resistance to motion, your inertia, the closer you bring your inertia to that turning point or that centre of mass, the faster you are going to be able to go, because you're concentrating all the mass into one spot. So think about trying to turn a pencil with one flick across a table. It's going to spin with a certain amount of angular velocity. If you try to apply the same force to a 30 centimetre ruler or a metre ruler, the same force applied is not going to travel with as much velocity. It would take a much bigger force because it has more resistance to motion. It's more spread about that turning point, about that axis. So, little introduction. Don't just dive into what you see and panic. Tell us what angular momentum is. Set the scene, because it's 6 marks. You need to explain the concept of angular momentum in relation to the dive. But let's start with this. Here's your introduction. Your next bit, let's paste this in. This probably took me, I'd say, 5 minutes to write, but I knew what I wanted to say. So you should always do a little plan. Maybe some key terms like up here, maybe a little rough plan on paper, or annotate the diagram. But feel free to pause and have a little look.